Hello everyone, my name is Oshada Jayasinghe and I will be presenting our work CeyMo on roads, a novel benchmark dataset for road marking detection. This research was done at University of Moratuwa with my colleagues Hemachandra, Damith Kawshan and Shenali A Kariyawasam under the supervision of Dr. Ranga Rodrigo and Dr. Peshala Jayasekara. Road marking detection is an important perception task in advanced driver assistance systems as well as autonomous vehicles. Yet we observed that it is comparatively a less researched area and lack of publicly available datasets is a major reason for that. Existing datasets also have certain limitations such as lack of challenging scenarios, lack of annotation formats, lack of proper evaluation methods, lower image resolutions, and the prominence given to lane markings. Addressing aforementioned limitations, we introduced the CeyMo road marking dataset, which covers a wide variety of challenging scenarios. We provide data annotations in three formats along with an evaluation script to facilitate novel developments in road marking detection. We also evaluate the effectiveness of using both instance segmentation networks and object detectors for the task of road marking detection. The resulting speed and accuracy scores for four selected models are provided as a performance baseline. The data collection and annotation process, we used two dash cameras mounted on four vehicles to capture street view video footage. The frames containing road markings are then extracted and manually annotated as polygons in JSON format using Label Me image annotation tool. We convert these polygon annotations to provide bounding box annotations in XML format and segmentation masks in PNG format. Our dataset consists of 2,887 total images with 2,099 images in the train set and 788 images in the test set. The images have a high resolution of 1920 by 1080. The dataset contains a total of 4,706 road marking instances belonging to 11 road marking classes. The testset is divided into 6 categories which are normal, crowded, dazzle light, night, rain, and shadow. The table on the left shows the number of instances present in each class. There is an inherent class imbalance between the 11 classes of the dataset. The chart shows the proportion of each category and the 5 challenging scenarios account for the majority of the test set. We use F1 score and macro F1 score as the evaluation metrics for the benchmark dataset. If an intersection or union value between a prediction and the ground truth is greater than 0.3, it is considered as a true positive. Macro F1 score is calculated by taking the average of the individual F1 scores. An evaluation script written in Python is provided to calculate these metrics. Moving on to the detection pipelines used for road marking detection. First, the object detection based approach. Each image is first transformed using the inverse perspective transform to obtain a bird's eye view of the road. A state-of-the-art object detector model is then used to detect road markings as bounding boxes. As the final step, the inverse of the IPT matrix is used to map these detections to four-sided polygons in the original image. As the object detectors, we evaluate SSD MobileNet v1 and SSD Inception v2. Next, under instance segmentation based approach, we evaluate two mask RCNN based networks with Inception v2 and ResNet 50 backbones to obtain road marking detections as segmentation masks. Moving on to quantitative results, this table shows the F1 scores and the inference speeds of each model. It is evident that the instance segmentation networks perform better than the object detectors but with a trade-off for inference speed. It can be also observed that all models perform better for the normal category than the 5 challenging scenarios. The class-wise detection results and the macro F1 scores of the 4 models are presented in this table. It highlights the tendency of the models to perform better at certain classes than others. Here you can see the visualized results obtained by the 4 models for 6 sample images from the 6 categories. It can be observed that the mask RCNN models perform better, especially in challenging scenarios. In summary, our work introduces CeyMo road marking dataset and we hope to address the limitations present in existing publicly available datasets. We have also evaluated two instance segmentation networks and two object detectors on the dataset as a performance baseline. You can obtain our dataset through this GitHub link. Thank you very much and hope you enjoyed our presentation.